Filtering, filtering, filtering. That's the topic at hand, and that's what we're going to be talking about in this particular portion of our presentation, because it's time for us to look at using administrative distances for the purposes of being able to select what routes we're going to install in our routing table. Now remember, in the confines of administrative distance, the lower the value, the better. And what we want to do is we want to recognize the fact that we have different prefixes and we have different ways of being able to represent administrative distance in the context of EIGRP. Now, what I'm making reference to is the fact that if I come in here and type show IP protocols, and I take a look at what I have in my configuration, the key elements that I'm looking at are going to be my internal and my external administrative distance. That's what this stands for. Now, that means that my internal prefixes are going to be an administrative distance of 90. My external prefixes are going to have an administrative distance of 170. Now we can look at that very quickly and very succinctly by going to R1, and what we're going to do is let's redistribute a prefix into our configuration. So what I'm going to say here is I'm going to show IP interface brief, E assigned addresses, and let's go ahead and create a loopback, interface loopback 200. Now what I'm going to do is I'm going to give it an address of all 100. So it's going to be IP address 111, 111, 111, 111, and we'll go ahead and advertise it as a /24. Now, what I'm going to do now is I'm going to redistribute this, but I don't want to just arbitrarily redistribute everything. So I'm only going to redistribute loopback 200. And to do that, I'm going to use a route map. Now the main goal here is going to be focusing on exactly how to accomplish that particular task. So first and foremost, what am I going to do? I'm going to create a route map, and I'm going to call that route map redistribute connected permit 10. Match, and what can I match on? Well, one of my options in my match configuration is going to be able to match on an interface. So match the first hop interface of a route. So let's see here. So I want to match interface. And what do I want to match? I want to match loopback 200. Now with that done, I'm going to exit my route map, do show run section route map. And there's the route map that I just created. Now how do I deploy this? Well, what I'm going to do is I'm going to go to router, EIGRP named, because remember we're in named mode. I'm going to go to my address family, IPv4 unicast autonomous system 10, and I'm going to say redistribute. But the problem is it's not going to let me use the command. Let's see here. Notice we have remote networks, but I don't have anything in here that's going to allow me to redistribute. And again, that's because of the fact that we need to be in the right configurational context. Watch here. We're going to say topology, and in the topology I'm going to say base. That's the topology I'm going to go in. And let's see what we have here. Notice now it uncovers the option of redistribute. So what I'm going to say is I'm going to redistribute connected, and I'm going to use the route map called connected or redistribute connected. Let me double check that and make sure that I spelled it properly. So it's going to be RED do show route map. There's what I'm looking about. RED greater than con. So that was right. So let's come over here and we'll say here, and then what I want to do is I'm going to identify a metric. I'll get myself out of the way here, and what we're going to do is I'm going to set up a seed metric. Now we'll talk about metrics more when we start talking about how we're going to be doing redistribution, but the main idea here is that I'm going to just simply generate this. Now what will happen here is we have this prefix that we just created, 1111.1111.1111.0/24, and that should now be propagated throughout our infrastructure until such a fashion that I should be able to find that on R22. Let's go over and see if that's indeed the case. Show IP route, EIGRP, and we should see a prefix for that 111.111.111.0, and notice it's an external prefix. Now all of our internal prefixes have administrative distance of 90. That's what's represented here. But what we see now is that we have an administrative distance of 170 for these external prefixes. Now, it still doesn't mean anything, because what will happen is if I'd come over here, let me grab my pen, I'll just throw this behind my ear, and I do a trace route. So if I trace route to 11.11 or 111.111.111, I'm still going to load share. So we're still using R2 and R3. We haven't really done any type of filtration. I'm just simply illustrating the fact that our administrative distance for these prefixes are appearing in our routing table based on their type of prefix. We have an internal prefix and we have external prefixes. Now later on, this is going to get a little bit more complicated when we talk about OSPF, but in the confines of EIGRP, it's pretty straightforward and simple. So if I want to see an external prefix, that means I have to have redistribution in my EIGRP environment. Now, with that said, let's look at what we can do to manipulate this, because what I want to do is I want R22. So scenario 1, R22, I want R22 to prefer R2 as the path to reach this network that we're advertising. Now, I can do this in a number of ways. But my first point here is that what I'm going to do is I'm going to illustrate the fact that we have two entries in our routing table on R22. Show IP route 11.11.11, 111.0/24, and we have two entries. I'll go ahead and grab my eraser and get rid of this. And the two entries that we see are via 2.1 and 2.0, so that's going to be R3 and R2. Now I said I wanted to prefer R2. Now the way that I could do that is that I could come in here and say, well, if I want to prefer R2, so I want R2 to be my preferred method of connectivity, what I could do is I could give R3 an arbitrarily higher administrative distance. Or I could come in to R2 and give it an arbitrary lower administrative distance, lower being preferred. Now what I'm going to do is I'm going to go in and I'm going to say I want R22 to let me know or tell me or pick this idea of R2 as its primary, and I'm going to do that by giving it a higher administrative distance. So let's look at exactly what goes into that process. So on R22, router EIGRP 10, what I'm going to say is I'm going to use the distance command. Now distance gives me a number of things that I can enter. Now first, notice it tells me I can set my EIGRP distance for my internal and my external routes. Now if I do that, that's going to be platform wide. So if I go internal, I could change my prefixes for my internal and externals, but I'm not going to be able to do that for the purposes of load sharing or traffic engineering with regard to being able to filter prefixes that I'm learning based on administrative distance. That's just going to change the administrative distance for everything, and we will review that shortly. What I want to focus on right now is the fact that I can come in here and say that I can give an administrative distance of 254, for instance, to a prefix, and that's going to be anything that I would learn from, say, a specific source. So in this scenario, I could say anything that I learned from 10.1.223.222, 3, what I want to do is I'm going to say I want to match that exactly. So anything I learned from this specific network or the specific IP address, so it's a host route, what I want to do now is I want to be able to impact that. Well, now what I'm going to come in here and do is I'm going to say, well, I am simply just going to say carriage return. Now what we're doing is we just affected the route from R3. Now what we'll find is this should reset itself. It should clear. And notice it cleared both connections, 2.1 and 2.0. It was actually applied under the routing process itself. My connections are now back up and operational. Now let's take a look at what's going on in our routing table. Show IP route, EIG, or show IP route. Let's look for specifically 111.111.111.0/24. and let's hit enter. Well, notice here what we're doing. Well, let's see, we've got load sharing going on. That's interesting. So let's see what's going on. Show IP route. Now notice, 11.11.11 we're load sharing for. Serial 2.0 and serial 2.1. Let's double check that. That's fascinating. Let's do a trace route to 111, 111, 111, 111, and we're punching it through, and what we see is we're load sharing. Notice we're going through R2 and R3. So that traffic is traversing our infrastructure like this, and it's being load shared. But that's going to be for this external prefix. What I want to do is I want to look at my internal prefixes. Well, if I look at my internal prefix, let's see what we do. Let's see, show IP route EIGRP, and what I want to do is I want to look at anything that's coming from R1 in the 11.11.0.0 to 11.11.7.0, and what do we see? We see that the only thing that we have is internal prefixes, but we have no load sharing going on. So let's do a trace route. So let's trace route to another test network. We'll use 11.11.0.11, and we notice that we're using R2. So in this scenario, what's happening is, let's go ahead and just grab this and take this out. What we're going to see here is to reach the network 111, 111, 111, 024, we load shared. We did load balancing. To reach 11.11.0.0/24, we're using R2. So we're using this path right here. And we can see that. R2, we see 11, which is cat 1, all the way to R1. Now, this is interesting, because what I did is I changed the distance, but I changed the distance, the administrative distance for my prefixes, but it only changed the internals. It didn't change that external prefix. Let's look at that. Because what I'm going to do is I'm going to illustrate the fact that that's exactly what happened. So what I'll do is I'll come in here and I'm going to shut down the link config T interface serial 2.0, and I'm going to shut this link down to R2. Shut. Now this means that I should be able to learn new prefixes. So notice here my state changed, and my EIGRP v4 relationship with 10.1.222.2 is now down. So let's take a look at our routing table now. Show IP route, EIGRP. And what do we see for these 11 networks? Now we're learning everything through 2/1, but look at what our administrative distance is. It's 254. Now, when we did this command, it did not change. We were not allowed to change the administrative distance for the external prefix using this command. Let's look at this. So, as we go through and we look at the configuration, bear in mind it's going to be 170 for this route. Now, in this scenario, we've given everything time to set up. So, show IP route 111, 111, 111, 0, 255, 255, 255, 0. And now notice we are not load sharing. Again, I got ahead of myself, and this is very easy to do. This administrative adjustment is adjusting everything that we have configured based on who we're learning it from. So in this scenario, let's look at this. Now, the thing is notice, like I said, our administrative distance is 170. Where is that? Administrative distance 170. So why did the prefix disappear? It disappeared because we shut the interface down. So let's go back and bring it back up. So config T interface serial 2/0 no shut. That's going to bring our link back in. Let's let our neighborship come back up. Show IP EIGRP neighbors. See 2.0, 2.1. There we go. Now we've got an adjacency. I'll go ahead and get myself out of this. No, new adjacency. Let's make sure that we are paired, and we are. And now when I come in here and I look specifically for this route, show IP route, notice it is load sharing again. So it's easy at first blush when you start turning interfaces off and reactivating things and making manipulations to get confused, to get lost in your troubleshooting or in your verification. This is really what I would call validation. So, I mean, the difference between verification and validation is that verify is going to be a series of show commands. To validate that something's going to work is where you go in and actually shut interfaces down and you start observing behavior. Something that I would not necessarily recommend that you do in the context of the lab unless it's a situation or scenario that you are going to want to validate whether or not it's actually going to work. Because if Cisco says in the event of a link failure, ensure that X happens, more often than not, my guess is they're actually going to go in and they're going to shut down that interface to see if everything they told you they want to have happen actually happens. And in that case, you would want to do a validation. But right now, what we see here is that that command that we entered had no effect on the administrative distance of this external prefix. Notice it's still 170. However, show IP EIGRP topology. Let's look at the topology table for anything that we're learning in the 11 range. Let's see here. So here we go. We've got 11.7. We're learning prefixes via 10.1.22.2 and 10.1.22.3. So they're both appearing in, here we go, 10.2.2.2 and 2.2.3.3. So they're both appearing in our table. Notice we only have one successor. We have one successor, but look, the metrics are identical. So the question is Terry, if the metrics are the same, why aren't I load balancing? I mean, if that's the case, shouldn't I be able to come in here, and let's see, double check the prefix that I'm verifying, which is going to be this one right here. So if I'm going to be verifying this or checking this, why can't I type show IP route and paste that in? I always want to do that, sorry. 255, 255, 2550. Why don't I have two prefixes? I have identical metrics. Because the metric doesn't come into play until after the administrative distance. The administrative distance is still associated with our particular prefix that we're learning. The metric is identical, but since the lower administrative distance is the more preferred, that's the one that's going to get picked. So we're going to be choosing the path through R2, not through R3. However, when we look at the contents of our topology table, so if I come in here and show IP EIGRP topology and paste in that 224 and I do enter, what we're going to see here is that I have my values serial 20. We have my successor. We have the feasible distance. The feasible distance is applied here. And as we go through and look at this, I mean, we also have that idea of hop count. We'll be talking about that. But I don't really see anything in here that's going to lead me as to why one of these prefixes is going to be placed in a routing table versus the other, given the fact that the feasible distance is the same. So all I want to do is make sure that you understand that and you realize that we have the capability of being granular. Now, what I did is I did the configuration on a per neighbor basis. I said specifically let's target R3 and give it an administrative distance that is going to be higher than, say, what we're learning from R2. I could have just as easily come in and say anything that we're learning off of this interface. And also what I want to do is I want to point out the fact that I can even be selective as to which prefix I want to do manipulations for. So let's look at that. So on this device, show run pipe section router EIGRP. We have this configuration right here. That's the out. There's our distance command. So what I'm going to do is I'm going to modify this. I'm going to say config T. I'm going to go router EIGRP 10. I'm going to take off the offset list. I don't want to use that anymore. So no. It's not affecting us. I just don't want to leave it on there. And what I want to do is I want to look at this distance command. Now in the confines of the distance command, so distance 254, 10, 1, 2, 2, 3, 3. So that's anything that we learn from R3. What I did is I said that I wanted to match that exactly. So it's going to be 0, 0, 0. And now notice I have access lists that I can work with. So let's say access list, we will say 7. Now the reason I picked 7 is the fact that what I want to do is I'm going to create an access list called access list 7, and I'm going to say permit, and what am I going to permit? I'm going to permit the network of 11, 11, 7, 0, and I'm going to hit enter. Now I'm going to go ahead and put an explicit deny here just so that we can see information coming in. So deny any. Exit, exit. Connection should clear. Show access list 7. Don't have anything yet, so let's see what's going on. Do show run section router EIGRP. Let's make sure I haven't screwed my commands up here. So anything that we're learning from 10.1.223.3, match exactly, match access list 7, and I said that I wanted access list 7, show access list 7. I wanted that to say anything that was matching 11, 11, 7, 0. So let me do this. Clear IP EIGRP neighbors. See if it brings my connections down. New adjacency, show IP access list. And let's see, 7 now has some matches. So I've got 4 matches, and I have 118 matches against my deny any. All I did was I took my implicit deny and made it explicit, just simply so I could see hits against it. If I had left it the way it was, yes, there is an implicit deny at the end of that statement, but when I do my show access list command, I can't see any hits against that implicit entry. So I just go ahead and make it an explicit entry, and it lets me have a warm fuzzy with regard to what's happening in my topology. So now I can see what's going on. So now let's take a look at this. Show IP route, EIGRP, and I want to look at my prefixes. I'm going to roll down to my 11, and the only one that I should have affected is going to be 11, 11, 7. Notice I have 90 here, but I'm not load sharing. So if I do a trace route to 11, 11, 6, 11, I'm going to load balance to reach it. So I'm going to R2 to R3, and I'm load sharing. But what happens when I go to 7? 7 is going to go straight to R2, down to Cat1, to R1, and we're not going to be doing any load sharing. Why? Because of the fact that I admitted administrative distance. Show IP EIGRP, and let's see, we'll say topology table 4, 11, 11, 7, 0/24, and notice I still have my 2 entries in my table. Notice they're both flagged as internal. My feasible distance is identical. 2195744, 2195744. And we're picking one over the other as a direct result of the fact that my administrative distance has been changed for this specific prefix. So not only can I do it based on my neighbor, my peer, I can also do it based on my peer and based on my network. Now I could take this a step further and begin walking through this and become more and more granular. But the key point here is this illustrates exactly what goes into this process. And it's this process that allows us to be able to do filtration in such a fashion that we can do traffic engineering in our infrastructure. Now, with that being said, like I said, we've done per neighbor, we've done straight configuration. The other element that I want to cover is going to be in the next presentation, and that's going to be how we can filter with route maps. So I'll see you guys in that presentation.